Everyone, let's have a discussion on coordinate systems. To describe a vector accurately and to express a vector in terms of its components, it is necessary to have some reference directions. Okay, such directions are represented in terms of different coordinate systems. There are various coordinate systems available in the subjects, out of which we are going to consider only three important coordinate systems. The first one is Cartesian coordinate system, and it is also known as rectangular coordinate system. The system will have three coordinate axes, namely x, y, and z, which are mutually at right angles to each other. Okay, these three axes intersect at the common point called origin. Right. There are two subdivisions of such systems. One is called right-handed rectangular coordinate system. The second one is left-handed coordinate system. Right-handed coordinate system where x-axis is rotated towards y-axis, and this rotation causes the upward movement of the right-handed screw in the z direction. For example, I just mentioned about right-handed rectangular coordinate system where we have three axes x, y, and z. And as I mentioned earlier, rotation of x axis into y, right handed. It is like, right? The screw will be moved upward, right handed. Similarly, there is another category called rotation of uh, x into y, but it is in the other direction. So you can find out that x and y axes are interchanged, so that you can find out that in the horizontal plane, instead of y, this is considered to be x, and this will become, okay, left-handed system. Or I can put it in this way: right hand is used, then the thumb indicates x-axis, and the forefinger indicates y-axis, and the middle finger indicates z-axis, where three fingers are held mutually perpendicular to each other. In the left-handed system, x and y axes are interchanged compared to right-hand system. This means the rotation of x-axis into y-axis through smaller angle causes downward movement of the screw, right-handed screw. Okay, downward movement of the right-handed screw, right-handed screw. So a point in the rectangular coordinate system, as you all know, will be represented or located by three coordinates x, y, and z. A point in the rectangular coordinate system. The point can be reached by moving from the origin. Moving from the origin is mentioned as O. The point can be reached. The distance will be, say for example, x in x direction, x axis, and y is the distance in y axis, and z will be in z axis. Okay. Consider a point having coordinates, say for example, x1, comma y1 and z1. It is represented as p x1, y1, z1. The coordinates x1, y1, z1 can be positive or negative. For example, I have a coordinate 3, comma minus 2, comma 2, right? You can understand 3 units you have to travel along x-axis and minus 2 units you have to travel along y-axis, and obviously 2 units along z-axis, right? Good. Similarly, we talk about certain things which is slightly beyond the coordinate system representation. Say for example, I have a plane like this. This is called as x is equal to constant plane. Parallel to which plane? Parallel to YZ plane. Similarly, I can think about a plane of this kind. You can understand that, right? All right. You have Z axis here, X axis here, and Y axis. Okay, good. Y is equal to constant plane, which is parallel to which plane? XZ plane, right? If it is so, can you draw a plane which is parallel to, say for example, XY plane? I can think about the right-handed coordinate system, X, Y, and of course you have EZ over here. This is called Z is equal to constant plane parallel to XY plane. XY plane. So, intersection of these 3 surfaces where x is equal to constant, y is equal to constant, and z is equal to constant planes will be one of the methods to define a point in the rectangular coordinate system. So the common intersection point of these 3 surfaces is the point to be defined, and the constants indicate the coordinates of the point. X is equal to constant, x is equal to, so intersection of these 3. Apart from this, we have base vectors. They are also known as unit vectors, which are strictly oriented along the directions of the coordinate axes. For example, when I have a coordinate system with reference axes x, y, z, you can notice AY is the unit vector oriented along y-axis, and AX is the unit vector used to indicate the direction of x-axis, and AEZ is the unit vector oriented along the directions of z-axis in a given coordinate system. So AX, AY, AEZ are called base vectors. Base vectors. For example, when I have a point P with the coordinates x1, 0, 0, this will be any point, will be a point on x-axis. Obviously, because y component is 0 and z component is 0, so obviously x is equal to x1. It can be represented by a vector. How to represent this as a vector? Joining the origin to this point. How to represent it? Say for example, x1 AX is the notation to indicate OP vector. By joining origin to the point P, I can create a vector, and the vector will be represented as x1 AX. So the base vectors are very important in representing a vector in terms of its components along 3 coordinate axes. Or I can even mention this as 0 times AY, and the 0 is along Z axis. So those 3 coordinates are converted into a vector. Okay. Similarly, I have a point called a position vector. Position, or let me call this as distance vector. Distance vector. For example, consider a point P whose coordinates are x1, y1 and z1. in a Cartesian coordinate system. So the position vector of point P can be represented by the distance of this point from the origin, or it can be called as directed from the origin. Directed from the origin to the point P, or it can be called as radius vector. Distance of the point P from O, or directed from the origin to the point P, or this is also known as, in a cuboid structure, radius vector. Why do we say so? For example, I have a coordinate system with x, y, z axes, where I can create any cuboid at this coordinate system like this. The diagram is roughly drawn, and you can understand that the point P with the coordinates x1, y1, z1, right? So what is the height of this component? This is z1, right? Similarly, this length is x1, this length is y1. Okay. In fact, more accurately speaking, this will be fixed over this axis to indicate the length and the height. Okay. So this is mentioned as position vector or radius vector, ROP. How will you represent this? This is represented as x1 ax, because coordinate of the origin will be 0, 0, 0. The coordinate of the point P is x1, y1, z1. So obviously x1 minus 0 ax, y1 minus 0 ay, plus z1 minus 0 az. The magnitude of this vector will be mentioned as square root of x1 square plus y1 square plus z1 square. Magnitude of this vector in terms of three mutually perpendicular components. So point P, for example, is a coordinate 1, 2, 3, and origin is said to be at 0, 0, 0. It is the point at which those three axes meet. So ROP, vector directed from the origin towards the point P, directed from origin to the point P, will be called as radius vector, and it is mentioned as 1 minus 0 ax plus 2 minus 0 ay plus 3 minus 0 az. Okay. So when you ask me to find out what is the magnitude of this vector, I used to mention this is 1 squared, 2 squared plus 3 squared, and the square of this sum will be the answer, square root of 14, that is 3.7416 something. So many a times the position vector is denoted by the vector representing the point itself. For point P, position vector is P, and say for example ROP is simply represented as vector P. Radius vector ROQ, for example, if Q is the point, then it is simply represented as Q vector, right? So it is represented in short form throughout the subject. In fact, for example, I have a coordinate system, rectangular coordinate system, right-handed rectangular coordinate system, where there are 2 points. For example, point P is at the coordinate x1, y1, z1, and the Q is another point which is located at x2, y2, z2. If you ask me to find out what is the distance between these 2 points, distance vector concept will come into picture, right? Because I know clearly that vector P is represented as x1 ax plus y1 ay plus z1 az, and the Q, radius vector Q, is represented as x2 ax plus y2 ay plus z2 az. So obviously vector starting from P directed to point Q, right? The distance vector is represented as the difference between, or I should say, Q minus P. Origin is Q, destination is Q, vector starts from P, so obviously this is represented as x2 minus x1 ax plus y2 minus y1 ay plus z2 minus z1 az. In terms of magnitude, if you ask me to find out, yes, I can find out it is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Is this okay? But to understand something extra, using the basic concept of unit vector, we can find out the unit vector along this direction. Along this direction is a, p, q. Vector, unit vector, for example, unit vector a, p, q. Okay, how to mention this? This is called unit vector along the vector distance vector pq will be calculated as pq to the top modulus of pq. So you can take it this way. It is x2 minus x1 ax plus y2 minus y1 ay plus z2 minus z1 az divided by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Okay, fine. If you are thorough with this, then I give you a question. Let me mention like this: 2 points. For example, point A, whose coordinates are given by 3, 2, 1, and another point B, whose coordinates are given by 4, 5, minus 4, 2, which are in Cartesian coordinate system. Obtain the vector, for example, A to B. What is meant by A to B? AB vector, correct? Distance vector, A to B, and a unit vector directed along this AB vector. Try to work it out and find out the answer. So consider a point P in a rectangular coordinate system with the coordinates x, y, z, and another new point x dash, y dash, z dash. So in rectangular coordinate system, always we will represent the points with the help of the corners of a cuboid. P and P dash. So the distance vector is like this. Let me tell you one thing: the length parallel to y axis is dy, and the side length parallel to x axis is dx, and the height parallel to z axis, okay, dz. Dx is the differential length along or parallel to x direction. Dy is the differential length in y direction. Dz is differential length in z direction. So differential vector, how will you represent it? dl is the vector dx ax plus dy ay plus dz az. This is the vector joining the point P to P dash. New point is the P dash point. Okay, distance of P dash from P is given by the magnitude, say for example dl bar, which is given by dx squared plus dy squared plus dz squared, right? So using this, there is a possibility for us to speak about the volume. Volume is simply the product of differential lengths in all the directions. dl is a vector, but if you look at dv, it's a scalar quantity. Okay. Similarly, I can tell you something about differential surface areas, ds, whose magnitude is ds, and the direction perpendicular to it will be indicated by an. Unit vector normal to the surface. Unit vector perpendicular to the surface. For example, I have a system. X is available here, Y is available here, and Z is situated. For example, I have surface parallel to ZY plane. So Y is plane, dy dz. But if you look at the vector perpendicular to it, will be ax. You have to understand this clearly, which indicates ds to the suffix x, which is indicated as the magnitude of the surface area multiplied by the vector perpendicular to it, or the magnitude of the surface area is given by dy producted with multiplied with dz, and the vector perpendicular to the small differential surface area is given by ax. Okay. Similarly, I can create a small surface. Yes, it is available in the plane xz. Okay. So anybody can guess this is dx and this is dz. Okay. The vector perpendicular to it will be, yes, what is that vector? Left out, ay. X, z are taken into consideration. So obviously the vector perpendicular to it will be ay. So you can simply take the surface area, differential surface area perpendicular to y axis will be dx dz perpendicular to y axis. Similarly, I can guess what is this? Yes, surface area available on, yes, this is x and this is y and this is z. So obviously the side lengths will be dy and dx, but the vector perpendicular to it is actually the az vector. Okay, so you can simply understand that this is equal to ds ez, which is equal to dx dy, and it is perpendicular to az. Okay, az vector. Okay.